Okay, everybody, the next question we're going to be working on is hasOne from the AP-1 problem set in the CodingBat website. So we have a question where we were going to write a method that takes an int, and we're going to return true if that int has a 1 in it in any of the digits. So for example, 10 has a 1 in it. Here it is. But 22 has no 1s, and 220 has no 1s. So those are false, whereas 10 is true. So basically, that's the story of what this question does. And then how you manipulate the number to get the digits is by using modulus and divide. So modulus 10, if you modulus 10, you get the rightmost digit because you're dividing this by 10 and you get the remainder. So for example, 22 divided by 10, the remainder is 2 because 10 goes into 22 twice with a remainder 2. So that's how that works. 10 modulus 10, remainder is 0. So it gives you that. And, we could look at other examples. If you're not too sure about modulus or divide, I would definitely ask me some questions about that or go do some research on how modulus and divide work. Very, very useful operators for AP and computer programming in general. Okay, so that's the story with the question. Searching the number using modulus and divide to get one digit at a time, and returning true if you ever find a 1. And if you get to the end, divide by 0. So that's the setup for the question. If that explained everything well and now you're good to go, then please pause, go try it out, and I'd be happy to tell you the answer when you come back. Okay, here we're back. Wow, through the magic of YouTube. And here's the answer. So hasOne is our method. Oh, I did this as a recursion. So we don't have recursion on the AP exam, just so you know. But I mean, I guess it's kind of fun to do it with recursion. I'll just explain how the recursion works. Maybe we'll convert it to a loop. Basically, our base case is if the number is 0, well, I guess there's no 1s in it, so I return false. And then if I do n modulus 10, I get the rightmost digit, and I find a 1, well, then I'll return true. Those are sort of my two base cases. So, this will happen maybe anywhere in the question if I find a 1, but this will happen at worst at the very end, because if I keep dividing by 10, eventually it'll turn the number into 0. And then the recursive step is I return hasOne and divided by 10. This is what cuts down the number. So just to take a look at an example for this, let's use 220. So n is 220. Is 220 0? Nope. Is 220 modulus 10 1? Well, 220 modulus 10, 10 goes into 220, 22 times, and the remainder is 0. So it's not 1. So then I return, no, I don't do anything there. So then I return hasOne and divided by 10. What's 220 divided by 10? It's 22. So then this method happens again, but this time n is 22. So it's not 0. The rightmost digit isn't 1, so then it divides it by 10 again. What's 22 divided by 10? So remember, it's integer division, right? So the answer is 2. All right. So we go back, but this time n is 2. So 2 is not 0, and 2 mod 10 is not 1. So we do it one more time. And this is where we'll get to the base case, this base case. So 2 divided by 10 is actually 0. 10 goes into 2 0 times. So now this is 0, and that'll trigger our case here, our base case. So looks like we got to the end and didn't find a 1, so we can safely return false. So I'll redo this as a loop. So if we were to do this as a loop, we could say something like while n is greater than 0. No, well, that is, yeah, I guess so. I think that'll work out. So what we'll do is, I guess we'll find out what the rightmost digit is. So if n mod 10 equals a 1, then we can return true, we found a 1. And then we could do n equals n divided by 10, Or we could use the good old assignment operator like this, and divide equals 10. I'm not sure what the pronunciation of that is, but basically we're taking n and replacing it with whatever n divided by 10 is. And then that loop will go over and over again until it gets eventually to 0. When n is 0, 0 is not greater than 0, so it'll stop. And then we can safely return false. I think that works too. Let's find out. Yeah. Okay, so there it is with a loop. And I'll leave it as a loop because this year we're not doing recursion, so no need to practice that. Although it's really cool, and you'll probably use it a lot when you get to university, depending on what you study. So up to you if you want to practice that one. Okay. Thanks, everybody. I hope you are finding these helpful.